One final way to be able to solve quadratics is by using this quadratic formula. And the quadratic formula suggests that if we have a quadratic of this form, ax squared plus bx plus c equals 0, then what we can do is identify a, b, and c and just plug it back into this formula and we can get two solutions for x, which is really nice because all this boils down to is a computation problem, right? Now, I'm going to show you in the first example that even though the quadratic formula works for every single quadratic, it's not always the most efficient method. Okay, so let's go ahead and solve this quadratic. First thing we're going to do is identify a, b, and c. And this has a coefficient of 1 in front of the x squared. So a is 1. And then the coefficient in front of the x term is 7. And then the final coefficient, or the constant c, excuse me, is going to be 10. And we're just going to throw it right into this formula. Okay, so x is going to be equal to the opposite of b, which is going to be -7, plus or minus the square root of b squared. Okay, so we're just going to have 7 squared minus 4 times a times c. So 4 times 1 times 10. And then we're going to divide that by 2 times a, which is 2 times 1. At this point, we've set it up, and now it's just simplify it. Okay, so when we simplify this, we're going to simplify under the radical first. We know that 7 squared is 49. 4 times 1 times 10 is going to give us a negative, or -4 times 1 times 10 is going to give us a -40. And then the denominator, 2 times 1 is 2. Simplifying under the radical, we get -7 plus or minus the square root of 9 over 2. Simplifying the square root, we know the square root of 9 is 3. So x is going to be equal to -7 plus or minus 3 over 2. And now we can split that up into two different types of simplifications. So we have -7 plus 3 divided by 2, and we have -7 minus 3 divided by 2. If we simplify this, -7 plus 3 is -4 over 2, and so one solution is going to be -2. -7 minus 3 is a -10 over 2, and -10 divided by 2 is -5. And so our solution set to this is going to be -2 and -5. Now, that's not the easiest way to do this problem, but it does work. And I know this instruction specifically said use the quadratic formula, but let me show you a little bit easier way to do this problem, or at least a little quicker way, is going to be by factoring, all right? And that's why I'm just illustrating this just to show you all that even though quadratic formula works all the time, it's not always going to be the most efficient method. And so if we were to factor this, 1 times 10, 10, magic numbers that multiply to be 10, but add up to 7, 2, and 5. It's an easy trinomial because it has a 1 in front of it, so we can skip right away to x plus 2, x plus 5. And so we would get the equation x plus 2, x plus 5 equals 0. And then we could set each of these factors to 0. And eventually we would get x equals -2 and x equals -5. And those would be the solutions to this, which is much quicker than going through the quadratic formula. But of course, you have to be good at factoring to be able to do this quickly. All right, so that's the trade-offs to the factoring method in the quadratic formula. Another example of this quadratic formula, 3x squared equals 4x plus 3. All right, so first thing we're going to do is we're going to set this equal to 0. We're going to keep the a positive, and we're just going to rewrite this as 3x squared minus 4x minus 3 equals 0 by subtracting 4x and 3 from both sides. This means that a is 3, that's the coefficient of the x squared. B is -4, and the constant c is -3. And what we're going to do is we're going to plug it into our formula, which is going to be x equals -b plus or minus b squared minus 4ac, right, all over 2a. And so we're going to get x is going to be equal to the opposite of -4 plus or minus the square root of -4 square minus 4 times a, which is 3, times c, which is -3. And we're going to divide all of that by 2 times 3. All right, so be careful with this -4, all right? It might be helpful to use parentheses as you substitute the negatives, okay? Same thing with the c equals -3. And so we're going to end up with x is going to be equal to +4, opposite of negative, plus or minus the square root. -4 squared is 16. -4 times 3 is -12. -12 plus times -3 is going to be a positive 36. So -4 times -3 is going to be positive 36 in here. And then finally, we're going to end up with divided by 6. All right. Now we have to be careful with this one, all right, because it's not going to work out really nicely for us, right? And that's one of the benefits of the quadratic formula is that if we get these types of equations that don't work out really nicely, then we can go ahead and still get an exact answer for this, okay? So just giving myself a little bit of room here. We're going to simplify this, and then we're going to simplify even more. And so this is going to turn into x is going to be equal to 4 plus or minus 1636 is 52 divided by 6. Now, we know that the square root of 52 is not a perfect square, but what we can do is we can factor it out a little bit because we know that 52 is 4 times 13. And that's one of the tricks that you all are going to have to do is you're going to have to simplify the radical 52, all right, by multiplying, by trying to find something that's a perfect square and something that's not. Right? Now we can rewrite this as 4 plus or minus 2 roots of 13 over 6. Right? And then finally, when we finish this out, we're going to wind up with, because everything's divisible by 2, this is a 2, this is a 1, and this is a 3. So our answer is going to be 2 plus or minus root 13 over 3 for x. And that's as simple as we can get with that. All right, so sometimes we get precise numbers like we did in example A. Sometimes we don't get the precise numbers like this one. All right, and we just have to leave it in this form. One example that's similar to that is going to be this last one where we have x squared plus 7x equals -8. All right, so we're going to set it equal to 0. So we're going to end up with our x squared plus 7x plus 8 equals 0. Right? And we're going to get that a is 1, b is 7, c is 8. We're going to go ahead and throw that into the quadratic formula. Okay, so we have x equals the opposite of b, which is -7, plus or minus the square root of b squared, 7 squared, minus 4 times 1 times 8. So that's 4 times a times c. We're going to divide that by 2a, which is 2 times 1. And again, we're just going to simplify this. So that's going to be -7 plus or minus 49 minus 32 divided by 2. And then we're just going to simplify under the radical. So we're going to get -7 plus or minus, this just becomes 17, 49 minus 32 divided by 2. And notice that 17 does not factor like the one that we saw before. And so this one, we're just going to leave it as is, all right? Another way to write this answer, not saying that you have to do this, but x's would be equal to -7 over 2 plus or minus the square root of 17 divided by 2. So if you wanted to, you could split this up into 2 separate fractions, all right? But we're just going to leave it as such. So hopefully this helps you understand how to solve these types of quadratics with the quadratic formula. The benefit is that we're able to solve equations that don't have precise answers, except for being able to keep with the radical. In other words, it's non-factorable. The detriment is that it takes a little bit longer for us to go through the computations than it might to factor.